We got a little buddy Nora here who's going to put some $4,000 into an account for 8 years at this percent interest rate. And we want to know what the balance will be if it's compounded first quarterly and then continuously. So this problem is designed to help you decide which one of these formulas is appropriate and make sure you know how to use it correctly. For all these formulas, this P stands for the amount you started with, and this A stands for the amount that you'll have in the future. That goes for this guy as well. That's the P you started with. That's the amount you'll have in the future. In all cases, the R stands for the interest rate. T stands for time in years. And then if you see the N, that has to do with when it's compounded in a number of times you can count. So, for example, in example A here, we know that the interest will be compounded quarterly. So that tells me I'm going to use this formula because I can count the number of times I would apply that interest, and that number of times would be 4 times in 1 year. We know that the principal, the beginning value, is at $4,000. The rate as a decimal would be 0.03 because we'd move this decimal point 2 spots to the left. And then the time, according to this problem, is 8 years. So if I put all that stuff together, the amount that she'll have after time passes will be that 4,000 she started with times 1 plus 0.03 divided by 4 to the 4 times 8 power. This calculation, I would do that in my head. It's 32. Then I would bust out the old calculator and turn it on and just type that in and see what happens. So if I take $4,000 and I multiply by 1 plus 0.03 divided by 4, close off that parentheses, and take that to the 32nd power, shazam, I see that she'll have $5,080.44. Now for the second problem, instead of compounding it a number of times we can count, it's going to be compounded continuously. And when we see that word continuously, that means we're using this formula where P, R, and T are as they are over here, and this E is that button on the calculator that's Euler's number. It's like that 2.718 we talked about. It's right here on my calculator. So if I plug it all in, the amount will equal 5,000 not 5,000, excuse me. It'll be 4,000 that she's putting in, e to the 0.03 times 8. And then this one, like, I could definitely do that in my head, but sometimes I can't, so I'm just going to do this all in the calculator all at once. So get the calculator out, I'll put in that $4,000, I'll press second ln to get the e to the power, and obviously my calculator, I'm going to have to, like, do this thing where I put the calculation in there and then close off my parentheses. Your calculators, I don't think a lot of you have to do that. It's just up there with the exponent. But they both need to be up in the exponent is the point. So if you don't have a calculator that gives you the pretty print, make sure you shut that parenthesis down before you press enter and find that she'll make, oh, just a little bit more money. $5,084. Oh, and 996. This 6 makes this round up to 005. So it'd actually be 508500. 5,085. 00. It's a lot of rounding going on there, but hopefully that makes sense. Good luck.